This is a quick overview on understanding how color works. Four components that are important for us to know are hue or color, the temperature of a color, the value, and the saturation. Here we see a grayscale at the top, 1 to 9. Grayscale actually is pretty infinite and goes beyond what our eyes can actually see, but typically an artist will work within 1 to 10, say, between white and black. The colors on the bottom there under the word value demonstrates how colors just out of the tube have their own unique properties of value. Most cases, but not all, color comes out highly saturated, so that's meaning that it's filled with pigment and bright. But some colors come out darker and some are normally just lighter, like yellow, for example. This chart on the right side demonstrates taking color right out of the tube, lining that value up to the grayscale that you make at the top, and adding white as needed to match the grayscale one way or another. So in the case of yellow, obviously it's a light color and it's going to be darker than white, but it falls within one of the lighter values like 2 or 3. And when you get to colors like magenta or purples or dark blues, you see how the actual color out of the tube starts under a much darker value range, and from there you add white until you match the aligned lighter value. This is a demonstration here of seeing value. It's kind of a fool the eye type of thing, and it takes practice to really pinpoint something that's highly saturated, or is it just dark? Value and saturation can get easily confused. So here we take the color out on the right and you look at that yellow block. Now, when you look at the yellow block on the color version, it stands out and is drastically different from the cloth. But when you take the color out, you see what happens. It actually, value-wise, is the same as the cloth. So some ways that we can kind of help ourselves is through squinting. If we squint, it minimizes detail and it just kind of narrows down our vision in such a way that we can designate or pull out value attributes a little better, as well as things like saturation. Here we get into temperature, and everything is relative. You have to remember that something is going to be warmer or cooler based on the thing next to it. That being said, our primary colors, which are very important to know and is demonstrated on the color wheel, handmade color wheel on the right, are blue, yellow, and red. Now, out of the tube, we can find warmer reds and warmer blues and vice versa, cooler of those three primaries. Overall, next to each other, we typically relate blue, for example, to blue water, blue sky. Red we might, associate with fire. Yellow we would no doubt associate with the sun. And so that helps us kind of determine something being warmer or cooler. So our blue obviously is going to be much cooler than the red and the yellow. And then when it comes to yellow and red, As a rule, particularly in the Impressionist color method, yellow is considered the warmer color. And that being because it's associated with the sun, and the sun is what warms things up when it hits objects. Here's an example of the same blocks under two different light conditions. The one on the right is a bright sunny day, and the one on the left is more of a gray day. We can see on the right the sun really warming up the tops of the table and those blocks. There's also a strong contrast that happens between the lights and the darks, and there are cast shadows. The one on the left has some differentiation between the tops and the sides, but you can visibly see a difference in the actual color. There's a more cooler feel, and it's closer to what's known as the local color or named color of the blocks and that tabletop. Here's an example of a landscape. 3 different light conditions. The bottom left has a more overcast, similar to the left block study, where everything is kind of flat and slightly cooler than the one on the top that is a sunny day. Even though there are clouds, those clouds move and they might create a shadow here and there. You can see on the left stack of beach grass a marked difference between the top of it and the bottom where the shadow is happening. This is potentially a high noon time of day, which doesn't create much in the way of shadows, but you can see the color of the grass, the color of the sand, even the water is totally different than the one on the bottom left, and it has a much warmer feel to it. The one on the right is completely different in its coloration based on the low sun down effect that happens as the sun goes down. Things tend to have a little more warm feel. There is, strong sun, so it's creating a marked difference between the lights and the darks, but there's a much warmer overall feel to all the objects. Here's another example of different times of year with the same marsh scene, and it clearly demonstrates the difference not only in the actual objects themselves at different times of year, but also how the light affects those objects. So we are getting a very strong feeling of warmth as the sun goes down in the top left, but it's a low light, so it's got a more muted type effect, whereas the ones on the bottom, even though they're a different time of year, it's a very bright, high sun effect on the coloration of those very same objects. Another example of a marsh scene at different times of day and in different times of light condition. We've got one that's more in the middle of the day. The light is sort of, sunny, but probably a little more high noon type sun. And the one on the left is when the sun is going down and everything starts to become more muted but warmer, and there's just a completely different coloration to the very same exact objects that are in both scenes. And again, another demonstration of a gray day on the left and a sunny day on the right, and you see the marked difference. The distant trees, those arborvitae, they're super warm on the right, and they have a much cooler, duller feel on the left in the gray day scenario. There's the contrast, like we talked about in the right, with the lights and the darks, and the tops that are getting hit with the sun directly are much warmer. You can see here and here, how much warmer it is than here and here on the parts that the sun is hitting it. So it's an entirely different color. It's, it may be in the red zone, but even then, to denote or to express that warmth on the right, we would go into something even different, such as a yellow or an orange, to express that strong feeling of sun in those areas. So this just gives you an idea that what we're trying to do is see with our eyes, like really express the difference in color that happens under the different light conditions. And so it's very important to know what's warm and what's cool in your color selections, what's highly saturated, what is value. Well, we've learned value is the lighter or darker part of an object, versus saturation is strong pigmentation. So it's going to be much brighter, have, be higher in chroma. These are different terms for saturation. And the colors that we choose to express that as a starting note are going to be different in these two different light conditions, but same exact objects.